Hypers! Welcome to Platinum, where future topnotchers are made. I am Veasna, together with Sophia and Anne, will explore Eicosanoids. Now, come on and join me as we make our journey to top 1. Let's start with a quick question. What happens when you accidentally bump your elbow hard? It gets red, it swells, it hurts. That's inflammation. But what triggers this response at the molecular level? That's where eicosanoids come in. Eicosanoids are bioactive lipids, basically small, fat-based molecules that act like local messengers or first responders. They're produced on the spot by your cells whenever there's an injury, infection, or even hormonal signal. They're not stored like some other hormones. Instead, they're synthesized de novo, meaning they're made fresh from scratch when your cells need them. Kind of like brewing a cup of coffee on demand instead of keeping it sitting in a thermos. So the name eicosanoid comes from the Greek word eikosi, meaning 20, because they're derived from 20 carbon polyunsaturated fatty acids, mainly the arachidonic acid. These molecules regulate a wide range of processes: inflammation, pain, fever, blood clotting, even smooth muscle contraction like in the uterus or lungs. So, you could say eicosanoids are the cell's emergency text message system. Super local, fast, and essential. Now, let's break them into categories. The big three groups of eicosanoids are prostaglandins, leukotrienes, and thromboxanes. Let's start with prostaglandins, or PGs. So these are probably the most well-known. They have a distinctive cyclopentane ring in their structure and are involved in processes like fever, pain, uterine contraction, and blood vessel dilation. For example, PGE2 is a key player in causing inflammation and pain. You might have heard of NSAIDs like ibuprofen, which block PGE2 production. For leukotrienes or LTs, they're formed through the lipoxygenase pathway. These molecules are critical in allergic responses and asthma. They cause bronchoconstriction and attract white blood cells to sites of infection or injury. There are also lipoxins, anti-inflammatory eicosanoids, and isoprostanes, which are products of oxidative stress and can be used as biomarkers in diseases like liver damage or obesity. The last one is the thromboxane or the TX. These are mainly involved in blood clotting. TXA2, for instance, promotes platelet aggregation and blood vessel constriction, like a patching system that kicks in during bleeding. So, if prostaglandins are the pain messengers, leukotrienes are the allergy alarm bells, and thromboxanes are the clot commanders. They all have unique but equally important roles in the body. Alright, now that we've gone over eicosanoids, prostaglandins, and leukotrienes, let's pause for a quick review. My first question is, what are eicosanoids derived from? If you know the answer, you can comment down below. And the answer is arachidonic acid. For our second question, eicosanoids are synthesized from membrane phospholipids. Is it true or is it false? Tap the like button if it's true and dislike button if it's false. The answer is true. Third question, which type has a cyclopentane ring in its structure? Again, comment it below. The answer is prostaglandins. And finally, leukotrienes are made via the COX pathway or the COX pathway. Is it true or is it false? Like for true, dislike for false. And the answer is false. If you got the perfect score, then you were really listening. Nice one! And if you got below 3, that's completely okay. It just means you need a bit more practice, and that's part of the learning process. Now, let's move on to the next subtopic.
Now, how are eicosanoids actually made? Let's walk through the biosynthesis pathway step by step. First is the starting point, and that's cell membrane phospholipids. All eicosanoids begin their journey from the phospholipids in our cell membranes. These phospholipids contain arachidonic acid, AA, a 20-carbon polyunsaturated fatty acid. But AA isn't just floating around free, it needs to be released. This brings us to activation through an enzyme called phospholipase A2 or PLA2. When a cell receives a signal like damage, infection, or a hormone, an enzyme called phospholipase A2 or PLA2 is activated. PLA2 acts like molecular scissors, cutting AA loose from the membrane. This free arachidonic acid is now ready to enter one of our major pathways. Let's dive into pathway 1, the cyclooxygenase pathway COX1-COX2. This is one of the most well-known routes. First, arachidonic acid gets converted into PGG2. This is the first oxygenation step by COX1 or COX2. From there, PGG2 is then transformed into PGH2. PGH2 is the central intermediate that can be further converted into various important eicosanoids, including prostaglandins, which are PGD2, PGE2, and PGF2-alpha. Their roles include inflammation, pain, fever, and smooth muscle contraction. Then there's prostacyclin, which is PGI2. Its role is vasodilation, and it inhibits platelet aggregation. And finally, thromboxanes, which are TXA2, TXP2. Their role is platelet aggregation and blood vessel constriction. As an example, NSAIDs like aspirin work by blocking COX enzymes, stopping this line of pro-inflammatory products. Moving on to pathway 2, the lipoxygenase pathways LOX enzymes. Here, 3 enzymes come into play: 5-LO, 12-LO, and 15-LO, and they convert AA into HPETEs, or the hydroperoxy eicosanoic acids. Let's start with the 5-lipoxygenase or the 5-LO pathway. AA becomes 5-HPETE, and then that leads to LTA4. Then LTA4 branches into LTB4, which attracts neutrophils, contributing to the inflammatory response. And LTC4, LTD4, LTE4, these are called cystenyl leukotrienes, or the cis-LTs, and they cause bronchoconstriction, which is key in asthma. Next, we have the 12-LO and 15-LO pathways. AA is converted into 12-HPETE, which yields 12-HETEs. Similarly, AA transforms into 15-HPETE, giving us 15-HETEs. From both, you can also get lipoxins like LXA4 and LXP4, which are involved in resolving inflammation. Think of them like turning off the immune alarm. Finally, pathway 3, cytochrome P450. Here, AA is metabolized by cytochrome P450 enzymes into HETEs, or the hydroxy-eicosanoic acids, and epoxides, or the EETs. These are involved in several key functions, including regulating kidney function, controlling blood pressure, and potentially playing anti-inflammatory roles. Let's move on to the next subtopic.
Now, let's talk about prostaglandins. So, what are the functions and clinical importance of prostaglandins? For its functions, first, they can lower or raise your blood pressure. Prostaglandins can act as vasodilators or vasoconstrictors, effectively lowering or increasing blood pressure. Second, they are involved in blood clotting. So, thromboxane A2, a type of prostaglandin, promotes platelet aggregation and vasoconstriction, which is essential for blood clot formation. Number 3, they can control gastric secretions. So, prostaglandins inhibit gastric acid secretion and promote mucosal protection. Number 4, they can cause inflammation. So, prostaglandins, particularly PGE2, are major mediators of inflammation, causing redness, swelling, fever, and increased sensitivity. Now let's talk about the clinical importance of prostaglandins. Firstly, they can help in pain inflammation management. Non-steroidal anti-inflammatory drugs or NSAIDs like aspirin and ibuprofen work by inhibiting cyclooxygenase or COX enzymes, which are responsible for prostaglandin synthesis, thereby reducing pain, inflammation, and fever. Second, they can help with labor induction. Synthetic prostaglandins like donoprazone are used to induce labor by promoting cervical dilation and uterine contractions. Third, they can help with stomach ulcers. So certain synthetic prostaglandins like misoprostol are used to prevent or treat stomach ulcers, especially those caused by NSAID use. Lastly, they can help with cardiovascular conditions using alprostadil, a prostaglandin E1 analog, which increases blood flow by expanding blood vessels. They can help treat conditions like cyanotic heart disease in infants and erectile dysfunction or ED. Now let's move on to leukotrienes. What are the functions and clinical importance of leukotrienes? For its functions, they can trigger response to inflammation, allergy, asthma, and immune response. So
So leukotrienes act as powerful pro-inflammatory mediators, promoting recruitment and activation of immune cells like neutrophils, eosinophils, and mast cells to the site of inflammation. They can also be allergic reactions and asthma. So succinyl leukotrienes, LTC4, LTD4, and LTE4 are crucially involved in allergic and asthmatic reactions. Now let's move on to the clinical importance of leukotrienes. So they can help with asthma and allergic rhinitis. Leukotrienes are key contributors to the pathophysiology of asthma and allergic rhinitis. Blocking their action is a major therapeutic strategy. So using leukotriene modifiers, leukotriene receptor antagonists or LTRAs like montelukast or zafirlukast work by blocking the binding of succinyl leukotrienes to the receptors on the airway of the smooth muscle cells or other inflammatory cells. But wait, before we move on to the next topic, let's have some short checkup questions. So the questions will be flashed on the screen and you have to pick whether they're describing prostaglandins, leukotrienes, or both. Number 1, they prevent or treat stomach ulcers, especially those caused by NSAID use. Number 2, leukotriene receptor antagonists or LTRAs are examples of its clinical relevance. Number 3, they are powerful pro-inflammatory mediators. Number 4, they are mediators of inflammation, causing redness, swelling, fever, and increased pain sensitivity. Number 5, they can act as vasodilators and vasoconstrictors. 3, 2, 1. Now compare your answers, and if you have any questions, feel free to comment down in the comment section below. But wait, we are not done yet. We have another game. So this time, we will have an interactive Canva whiteboard link. A Canva whiteboard QR code will be presented on the screen, and your task will be to fill the Venn diagram by comparing and contrasting prostaglandins and leukotrienes. The QR code will be flashed in 3, 2, 1. When you click into the QR code, a Canva whiteboard link will be activated and you have to fill the Venn diagram by comparing and contrasting prostaglandins and leukotrienes. Okay, now that we're done with the game, let's move on to the clinical relevance of eicosanoids. So eicosanoids are central to the inflammatory response. Non-steroidal anti-inflammatory drugs or NSAIDs alleviate pain, reduce fever, and diminish inflammation. They also help with cardiovascular health. Low-dose aspirin is widely used in cardiovascular prevention because it selectively inhibits platelet COX-1, thereby reducing TXA2 production and platelet aggregation, offering antithrombotic effects. They also help with blood pressure regulation because they can cause vasodilation and vasoconstriction. They also help with respiratory diseases using targeted therapies or leukotriene modifiers to either block leukotriene receptors or inhibit their synthesis. They also help with gastrointestinal protection and disorders using synthetic prostaglandins to prevent or treat NSAID-induced ulcers. They help also with the reproductive health using synthetic prostaglandins like vonoprazan and misoprostol to clinically induce labor, ripen the cervix, and terminate pregnancy. They also help with ophthalmology, specifically glaucoma treatment, using certain prostaglandins like lanaprost and travoprost, which are a first line of treatment for glaucoma. Lastly, they also help with renal function. Prostaglandins produced in the kidneys influence renal blood flow, glomerular filtration rate, and the excretion of sodium and water, thus contributing to the overall blood pressure regulation and electrolyte balance. Before we end, let's have some short checkup questions. So the questions will be flashed on the screen and you have to pick whether the statement provided is true or false regarding the clinical relevance of eicosanoids. Number 1, eicosanoids are central to the inflammatory response. Number 2, synthetic prostaglandin analogs like misoprostol are sometimes used to treat or prevent all ulcers. Number 3, prostaglandin analogs like latanoprost and travoprost are a first line of treatment for glaucoma. Okay, that is all, and now the correct answers will be flashed on the screen in 3, 2, 1. Compare your answers, and if you have any questions, feel free to comment down in the comment section below. That's all for our lecture today, and thank you very much for listening. And remember, strive, excel, succeed. This is Flat 1 Nom, where future top notchers are made. See you in the next review.